Hello, my name is Brian Myers, and I'm going to do a tutorial on reusable boosters. Now, I am a virtual nobody in the YouTube Kerbal Space Program world, so I figured I should probably show you what I hope to teach you so that you don't have to see this, after 30 minutes of listening to me go on and on about how to build a rocket. These are, what you're looking at is a compilation, highly sped up of course, of my last 7 career mode launches. All of these boosters are coming down within about 1 kilometer of the center of the runway there, where that blue waypoint is. And I'd used no quick saves in order to get this kind of accuracy. These are all first landing attempts for those missions. And this is fairly easy to do. You just have to take a few modifications to your boosters, which I will show you, and then a few techniques on how to land, which I will also show you. And why do this? Well, 2 reasons. 1, save funds, and 2, save time. And for time, you'll spend more time engineering a single booster, but you'll get to use it over and over and over again. I've used this one, I don't know, well over 20 times, maybe 30, and it works quite well with practically no modifications. And as for funds, well, let's say that each of these had flown a single satellite placement mission. Those typically get you about 110,000 in funds. Those launches cost me about 11,000 a piece. And if I'm able to string them together, I can actually launch 3, even 4 satellites per launch. And those satellites are actually capable of doing, usually changing orbits around and getting a couple of those missions completed. Each one, so I can make quite a bit of money out of one of these launches. I could probably make 800,000, though I haven't been able to line up that many contracts to do it once. If you are throwing away these boosters, you're throwing away just 30,000-40,000 per launch. So my cost is just the fuel, the monopropellant, and I'm typically recovering all but about 2% of the parts you see. And with one small modification, I can even return a payload from orbit. These are canisters that are now empty that took supplies up to the space station. So I'm now bringing them back and recovering those. My goal is to recover everything and leave no debris in orbit. So there you go. Hope I got your attention. Let's go to the VAB and we'll start with how to convert a typical booster to a reusable one. Okay, I have a typical 2.5 throwaway booster here that I'm going to convert into a reusable one. Then I'll show you how I kind of supercharge that for my booster, which you saw in that previous intro. Then I will go into how to test your booster, what to look for, some tests you should run, and how to in what order to do those tests. So you can just kind of discover the envelope that you need to fly within to keep this thing safe and recover it. And then finally I'll do one launch so that you can see the method I use to actually land this. On this booster, we've got fuel, of course. We have an engine, we have some fins for stability, because everybody knows you got to be stable, right? We have an SAS module for control, we have a stacked coupler. Presumably the batteries, if there's monopropellant, etc., would be part of the control module, would all be part of a payload up here to control this and power this with electricity. And the moment you detach this, it would probably either stay up in orbit because you have no way of controlling it, or it would fall back into the atmosphere and be removed by the game once it were 2.5 kilometers away from you in the vessel that you are controlling. So let's look at this. Now there's one big problem with this booster entering the atmosphere. Let's look at stability right now. If I fill this full of fuel and I look at where my center of mass is and my center of lift, I see a super stable launch vehicle, super stable booster. The booster will pivot around this point here, the center of mass. The airflow, the wind, so to speak, its center of effort, where it's pushing against, would be right down here. So if we're moving up and we start to deviate from straight line flight, like let's say that we, let's see, I gotta figure out which key it is. Here we go. Oh, look at this. So let's say that we're still going straight up, but we've managed to pull the top of this vehicle away from the direction it's traveling by this much. The air is pushing down here, and there's some leverage here. You can kind of see this from where draw a line vertical and then draw a line horizontal. That's the amount of leverage that the air would have in pushing this vehicle back into center line. So actually it would be pushing, I should have done this over on this side here. So it would be pushing it here to move it back to stable flight, which is like this, with the center of lift behind the center of mass. If we're traveling up, this would be behind. So that's great. This is actually so stable it would be hard to steer. The moment you let go of the controls, it's going to snap right back to being pointed in the direction it's traveling, being pointed towards prograde. Okay, so let's make this recoverable. Now, what I've seen people do is they go, okay, we got to slap some landing gear, of course, right? You know, everybody knows you got to have landing gear. And everybody knows you're going to have some sort of control. So let's throw a probe core on here. And let's not eject the probe core. Let's just stick it right there. Whoops. Right there. I know that looks funny, but just bear with me. We all know that if this runs out of power, we're hosed. So we need to add some batteries. So I do have a lot of mods. It's hard to find these sometimes. I'll just stick 4 batteries on there. I don't know how many we need. And we can see we can snap this back on. Now, forget that there's a big gap here. I could fix that if I wish, but it would just be a waste of time. And maybe they would say, oh, we need some parachutes. So we'll throw some parachutes on. I'll put 4 on just for laughs. And let's see, and maybe some solar panels, right? Actually, let's leave those off for now. Okay, so now we have a booster here. Now, assuming this can get its payload into orbit, we have control, we have electricity, we have parachutes, we have landing gear, so we could do a deorbit burn and land this. But what happens when this travels backwards through the atmosphere? So now the nose is where the engine is, right? So what happens? Well, we've used up all of our fuel. And this is what it looks like coming down. Now our center lift, remember this is the front, is going to be way in front of the center of mass. So the moment this deviates, if you had to steer this a little bit, or it might even happen from just kind of a random little occurrence here, the air is going to catch a hold of this, probably all the way down here at the fins, and it's going to want to spin this thing around. It's going to end up flipping it over like this. And in doing so, a lot of times the rocket will rotate so quickly that it will overpower all of its little nodes here holding things together, and it will just disassemble itself and fall apart and maybe explode. In addition to this, you don't want to re-enter like this because you don't have a heat shield up here. Engines can withstand a whole lot of heat. Other parts cannot. Does this show me? It doesn't show me right now. I'd have to go find it to show you how much heat it can withstand. It's probably, I don't know, it's like 1500 or something. So this is a problem. This is what we have to fix. Another possible problem is that this center lift is offset a little bit. Like, what if I can demonstrate that here? I mean, this would be obviously a bad thing to do, but I'll just use this to demonstrate. Say I put one wing over here. It's not really showing me the problem here. Tell you what, let's say I had used it's in structural. Let's say this is the early part of my career and I'd used one of these. This thing, pretty sure this is a bug. Look at where they put the center of lift on this. That's pretty ridiculous, and the problem here is that if you land a vehicle like that, like I have, this guy right here I believe uses that part. Yeah, this is a very tricky vehicle to land because what's going to happen here, the center of lift is not in line with the center of mass. See that? Now I did some things here to try and line it back up. I did a few little tricks, but still what we'll try to have, what this will do is actually kind of corkscrew through the atmosphere, which, you know, then you're kind of, as it corkscrews, you're using lift to, it's using lift to steer it around. It's going to get very inaccurate very fast. So it's very difficult to land this thing on target. I'm going to go back to my booster and I'll show you how to fix this problem. Okay, so now we know we need to, when this is empty of fuel, we know we need to be stable going in a downward direction. So what we can do here is, okay, there's my center of lift. I'll put this right about here. So just stable enough here that it's around the edge of this ball. Let me zoom in here so you can see that. That's a really good place for it. It'll still be fairly easy to steer if you have to, but it'll generally keep going in a straight line. And the other thing is that, what I didn't mention before, is that you need to build in symmetry. Some people will, I'll see them strap on a booster and then they'll strut it. The strut goes, you know, like let's say it's starting here and it goes like this. Well, as the wind hits that from the top, it's kind of like a fin. It's going to make this thing spin, and we don't really want that either. So you need to build in symmetry. You need to not do that with struts. So we know this will come down. Now let's see what happens as it goes up. Okay, so we're still stable here, and as we burn out our fuel, Kerbal Space Program uses the top tank. Okay, right about here, we are now unstable. So this would be starting right about there. Okay, that's still full. So if this happens high enough up in the atmosphere is super, super thin and it's not going to try and, you know, take control of your rocket, then that's fine. And that would happen generally, I don't know, around 30 kilometers if you're using Ferrum Aerospace, probably higher if you're using stock. Then this is not a problem at all. What I could do is I could try to fine-tune these fins, but you know, I tell you right now I could spend a few minutes doing that and I probably wouldn't get it perfectly right. So we have a problem here, and this needs to be fixed in some other way. And I'll tell you right now that we can solve this and a bug here at the same time. So how we're going to solve this is this. I'm going to go ahead and pull this off, and I'm just going to add a very small fuel tank to the top and bottom of this launch vehicle. There we go. Okay, now what does this do for us? So this engine, I'll tell you right now, has plenty of thrust, and we're not taking away anything from here. What we've done, let's say that we're going to use some fuel for our deorbit burn, right? We know we're going to do that, and I'll tell you right now, you need at least 400 delta V for that. It's about half of one of these tanks. So I'm going to go ahead and launch this with this tank locked off. So now, this one have fuel? Yes. This one have fuel? Yes. This one does not have fuel. So now, as see the center of mass has moved up, so now as I burn down through here, Okay, so now this could be a problem. So we've burned a little more fuel, and we're getting there. We're getting there. Still not enough progress here. So now notice that I added weight up here, and this is a little bit of weight, but it's really far away from the center of this, so it has a lot of leverage, and that's why it has such a big effect on that center of mass. So I can do one of two things here. One is I could keep fussing with this and maybe add some more fuel up top until this would stay balanced all the way through its cycle. Let's see if I do this real quick. Okay, that's locked off still. And now I could probably burn out. Oh, look at this. So as I burn this one out, the center of mass actually goes up because this tank is below the center of mass. So I've now effectively solved this problem with both of these tanks. So now if I burn this down, it just gets more stable. That's good. And same would happen with this tank. This is even further down. So maybe I don't want to carry that much fuel, so maybe what I'd do is I'd launch this and then maybe at 40,000 kilometers up, towards the end of it, or maybe even right before the circularization, I would go ahead and open this tank up, or maybe this one, and let it burn that fuel. Now, coming back down through the atmosphere, if one of these was my reserve tank and I've burned out everything else, I would manually transfer the fuel from top to bottom to make this even more stable coming down. So then it would look like this, and that will be stable coming down as well. So I call these trim tanks. It's a sailing term. Move some liquid around here to help balance the boat out. Another way you could solve this is just by constraining yourself with a minimum payload weight. This tank right here weighs 4.5 tons, so if I put 4.5 tons up there and I don't have this tank, right? Whoops. Like, let's say this tank is the payload. This is another stable situation, and this would remain stable going all the way up as well. This would be my reserve tank. This would be my payload. There's my worst case scenario. My center of mass is still in front of my center of lift while going up, and I already know the downward situation would be fine because this would be removed at that point. Okay, now we need landing gear 2. I forgot to put that back on after I took them off. If you're using stock KSP, you really need the big landing gear. Whoops, I'm in the wrong section here. Which would be, where are they? There we go. You need these landing gear, and you have to overcome the problem that they don't reach below the engine. So what you can do is do this little trick right here. You got to find a nice structural piece to mount these to. On this one, I probably need a long one like this. I'm going to use Kerbal Space Program's new feature here. Whoops. Rotate. There we go. Angle these down something like that. And I'm going to find some way to mount these guys on here. This is always fun. Is that? Nope, not even close. Okay, rotate. There we go. There. Totally silly. You would launch like this, and of course you'd put these down right before landing. Okay, let's move on to testing this rocket. Now, we're going to try and figure out what some of the key envelopes are for this vehicle. A flight envelope would be like, if you're flying a plane, this particular plane at 20,000 feet, and you pull more than 4 Gs at 500 knots, the wings will stall and you will crash. So don't do that, right? Only pull 3.5 Gs. That's the edge of the envelope. So what I like to do is I will test the kind of the critical aspects of this launch from backwards to forwards. So the very last event that has to happen is that this needs to sit upright on the grass on top of the landing gear. So, and I'm going to do this as a worst case scenario. I'm going to make this even worse. I'm going to use, let's say you're doing this like really early on, because I want to make sure this fails. And you're only using the small landing gear. And what I would do is I would test this in its worst possible scenario. And the worst possible scenario is if you have monopropellant up here, that's full. I think the worst possible scenario is that these fuel tanks are actually empty, because if you have more fuel, what you would do is probably do a more aggressive node burn out of orbit, which is actually more accurate anyway. You're only going to reserve about 50 delta V for touchdown. Okay, well actually look at that. It fell kind of onto the engine, so I'd say that that's a failure right there. What you would see if the engine were not touching and these failed is that the suspension of one of these would probably just kind of break, and this whole thing would just topple over on its side. And if that starts to happen, you can't recover it, and it's a total loss. And if that happens, I got to replace the landing gear. Well, that means I've changed, my whole configuration, and any test I did up to this point is now invalid. I have to test it all over again. So I want to make sure that this test passes before I move on to the next one. Alright, let's recover this, and I'll show you the next test. I'm going to beef up those landing gear too. Okay, oh, and by the way, when you do tests, you should always copy your entire save game folder. Design your vehicle, copy your save game folder, then load that save game and do your testing. Because you can have some horrible mishaps. I have actually bounced these vehicles. That's another test I do sometimes, is I will, well, let's just go ahead and do it here, because maybe the thing will spectacularly explode again, which is always cool. Okay, I don't need all this fuel. And I'm going to deploy these guys, and let's launch. Okay, the bounce test. Okay, so what you do at the bounce test is, get my staging right again. Okay, is I'm going to kind of hop up and down. I'm going to fire the engine, and then cut and try to land here at 6 or 8 meters per second, see if the landing gear can take it. And I'll show you why you want to do this in a copy of your save game. Okay, it's 6 meters per second. That's why. That always cracks me up. The rocket actually survives that, which is really ridiculous. What made the engine blow up was kind of secondary explosions. You can throttle up and take off and leave the launch pad there just burning. And that's like $1 million launch pad right there, after you do all the upgrades to it. Okay, now the next test is the parachute test. And what I want to know is, if I come down on these parachutes, are they going to have enough stopping power to land at a speed where I'm not just going to smash the landing gear and everything down here to pieces and have the whole thing fall over and explode. So I'll go ahead and test this with 4. I know that with 2 this thing would crash, so I'm not sure what would happen with 4. Now I actually have to do a little bit of actual flying for this, so I'll go ahead and fuel this up. Would that be enough? Yeah, I'll fuel this one up too. I don't need a whole lot. I just need to get up enough that I come down with a reasonable amount of speed. Okay, gotta fix my staging real quick. There we go. Okay, I'm gonna throttle up. I'm gonna steer a little bit away from the KSC. I'm going to turn down my audio volume here. Let's see, UI, ambient spacecraft. I'll cut all this down here. Okay, I'm out of fuel. Ooh, bad stability problems. See that? That's because I didn't have my minimum weight up top here. It'll probably flip around again and go engine first on the way down, since I wanted to go engine first on the way up. Okay, picking up speed. I'm going to wait until I see my speed slowing down slightly, just due to the thicker atmosphere as it comes down. I'm at 190, 200, 205, 206. Now it's slowing down. Deploy chutes. Better deploy my gear too. We'll get another gear test out of this. Not looking good. Right. That means you need more parachutes. Okay, so at this point I would add 2, maybe even 4 more parachutes, judging by how fast I hit, and I would give that a try again. And what I need to do is I need to keep adding parachutes until my landing speed is, about 8 meters per second. If I want to be successful in a water landing, I need to get that down to like 3 or 4 meters per second. I would correct this silly, thing right here. I would actually offset this down. Well, here, I'll just go ahead and do it. Watch this. There. Save that. Looks a lot better now. Okay, what was I going to do next? Oh yes, how to prepare this for launch. Now that we know we have a good vehicle, what I'd do is... Actually, I would do this after my test flight, but since we're in the VAB, I'll just go ahead and show you. Okay, did I lock this off? Yeah, okay, that's the configuration I want to launch it in. Now what I do is I put a capsule on there and I change my root part. I select this button right here, root. I click on everything but the part, and then this is my new root. So what this means is I can now detach this all by itself, and I'm going to create a subassembly here. So drop there, and I'll just call this test booster, and save it. Did it save? Okay, I guess it did. Now let's say that I'm going to go launch a payload. I would take my payload, like, I don't know, like maybe it's this. I go to my subassembly, and now my test booster is right here. Now the node that it was connected to the old root part, is the only node you can connect it to now. So you got to make sure you get that right. Slap that on there. And then all I need to know is, does this meet the minimum weight? You probably have in the notes of your booster here what the minimum weight is. And do you have enough delta V to get that to wherever it needs to go? And I'll leave that for a whole nother discussion, because there's lots of tutorials on delta V and how much you need and all that stuff. Okay, now I'm going to do a flight with the booster you were watching in the intro. And I use a lot of mods, so like I just showed you, you don't need these, but I like them a lot of times for aesthetics, sometimes for ease of use. Some of them make the gameplay more challenging, more realistic, etc. For instance, I'm using Ferrum Aerospace, which is better for aerodynamics. I'm using Deadly Reentry, which will simulate burning up on reentry. And I have a whole bunch of mods that are just parts. So this is the booster. I'm going to go ahead and test fly and show you what to do with in space. Now, incidentally, I've kind of maximized this booster, and that might be worth showing you here real quick. One thing, I haven't mentioned before, I forgot this. I think there's a bug with the mainsail engine when it's connected to the big orange tank. I noticed that it overheats, I don't know, 6-7 times faster than it normally would. And I haven't tried that in stock, so I can't confirm that's a bug just yet, but having the small fuel tank down here actually eliminates that bug. It's fine when it's attached there. So to maximize this vehicle, I've done a couple of things here. For maximum use, maximum different types of missions I can accomplish, instead of using a stack decoupler, I put a docking node up here, which is how I can dock a payload to it to bring it down out of the atmosphere, or down out of space, and land it. I have also, just for aesthetics, I've put all of the monopropellant, batteries, etc. See if I can get a good view of this. Up here on top, this is a universal storage system container. It's called the octa-core, and it has a bunch of little storage units along the side, and in those you can place things like 2 little monopropellant tanks, 4 batteries, and a couple of the extendable solar panels will come out here. One here and one here. My probe core is down here. I have a mech jeb unit attached here. Looks like there's some strut connections in there that aren't working. I should take those out. And then this is the base of the fairing. And by the way, try and get this back on top. Get this back up here. So you'll notice that I have hidden all of that stuff. Inside the fairings for kind of a nice clean look. But you don't want to put the parachute in there. I have noticed that if the parachute would go right here on top of this, this node does not happen to be very strong, and I've never seen one of these withstand the parachute opening. It will just rip right off the rocket. Had a weird KSP pause right there. Come on. Come on. No. Okay. Moving down the rocket, I have a real chute pack right here. Real chute's really nice because instead of doing all that parachute testing, you can open up an interface here and tell it, you know, hey, I want 3 parachutes just mainly for looks, and I need this thing to land at 3 meters per second, and it will resize the chutes and do what it needs to do to make that happen. From KW Rocketry, I have this SAS unit here. It acts like a collar around the top fuel tank. KW Rocketry again, 2 fuel tanks here because I like the looks of those better than the dirty looking gray oil drum tanks that the stock version provides. Another one of those down here. I have lots of little lights around it just for looks. I've got monopropellant here and here, top and bottom, because this is a big vehicle. It's hard to push that around with small thrusters. And I have a Kerbal attachment system, I think is the mod, for just a fueling nozzle right here, which I actually haven't used yet. And in addition, I kind of figured out that I could put one more little fuel tank up here, eke out a little more delta V on that, and launch. I should be able to launch about 20 tons into orbit with this. Someday I'll try the max test, but not now. What I wanted to have happen was to run out of my 2 main resources for a booster, which is thrust to weight ratio and delta V, both at the same time. Sometimes you end up with not enough thrust to weight ratio, sometimes you end up with not enough delta V. If you run out both at the same time, I think you've maxed out what you can do here. Okay, let's fly this thing. This will be a test flight. Normally I would do a full flight top to bottom. On this one, I'm going to do something slightly abbreviated here because I'm just doing this video. Okay, remember, this would be my reserve tank. As I reach orbit, I would probably have almost none of these. And by the way, this is single stage 2 circularized orbit. Now, if this were a real launch, I would have to have kind of an idea of this payload, how light it is, how big it is. If I were to, I have actually built a station with this, and one of my launches was very light but very big, and it was actually as big as the rocket, extending all the way up here with a massive fairing around it, and it played havoc with my center of lift. So you should actually, you know, with your payload on top, drain these tanks and make sure that all the way up you're going to be okay here, like I showed you earlier. Okay, did I fuel these yet? That's right. We don't need fuel, we don't need fuel, we don't need fuel. Okay, let's launch. Okay, so if this were for real, I would do 2 flights. I'd do one with a modest payload, just to put it through its paces and make sure I can get all the way through its paces, all the way to a successful landing. And then I would try with max payload just to confirm what my max payload is. And back in the VAB, I would put those as nodes up into the vehicle information up top. For this one, because I'm just doing a tutorial video and you're interested in seeing how this lands, I'm just going to cheat this thing up into orbit. Let's see, yeah, I'll put it into a 90-kilometer orbit. Oh, don't know what that was all about. Deadly Reentry is having fun with me. I don't think it blew anything up, though. Okay. So incidentally, you know, usually your launch is broken up into 2 parts, right? The ascent into a suborbital trajectory. You coast up above the atmosphere, then you circularize. As soon as I break the atmosphere, maybe even a little bit earlier than that, I would jettison my fairing so that it would fall back in. Fairings don't get circularized. So I'll jettison that right now. going to use MechJeb here to help me out to make this a little bit quicker. Now, the other thing I highly recommend is that you detach your payload when you're facing prograde, because your booster's next move is to flip around and burn the other direction, and that way they go away from each other. I actually did do one where I released the payload in retrograde, and about 4 orbits later I was messing around and finally I went to do my deorbit burn. Forgot all about the payload, and I started accelerating to deorbit and flew right into the payload, which is like a 1 in a million thing, but it made a successful, or a spectacular explosion. It was awesome. Okay, so what I'm going to do is open up my fuel tank. I'm actually going to pump all of this down to the bottom. This would be critical if you were doing a full stock landing attempt, because you would probably, my recommendation for that is actually to lower yourself into the atmosphere, from far away, and then do a hard burn at around 30,000 kilometers somewhere over the mountain, and you're just going to have to kind of judge it and judge how you're going to land and how you're going to do that burn. But for that, you definitely have to carry this weight down close to the engine for the stability reasons I told you earlier. Okay, the other thing I'm going to do, I should get my orbit information here. Now, this is one of the mods that I'd say is nearly required. You don't have to have MechJeb. There's several of them out there that will give you these numbers. Really what you need are access to your actual orbit numbers. So what I have is time to my equatorial ascending node, time to my equatorial descending node, my inclination, etc. I'm going to intentionally mess up my inclination right here, because usually in a launch you don't get right on 0 degrees inclination. Okay. Just gave myself a half a degree of inclination. That may or may not get me to the KSC. I might land in the water on either side, so I need to fix this, and this is the first thing that you got to do. So I'll look at my numbers here, and I'll see that my equatorial descending node is in 15 minutes. If it's a descending node, that means I'm passing from north to south as I cross the equator, and I didn't detach my... Okay. You know what, I'm going to take some of this fuel right here, because I just had to do that inclination change. Okay, I'm going to aim this prograde. Okay, it's close enough. I'm going to undock. And I'm going to reverse thrust a little bit to get away from it. Okay. Now, back to business. So what I was saying was that my inclination now is not 0. I want to get this right on 0. So I have a descending node coming up in 14 minutes. That means I'll be heading from north to south, which means I want to burn from south to north. In other words, I want to point north. On the nav ball, that would be along the horizon here, right at 360. I'm going to go ahead and let MechJeb do the flying just to make this quicker. Okay, now I'm going to warp around to the equatorial DN. Okay, 40 seconds away. Now, I've been in orbit for a while. Yeah, my electric charge is getting low. I'm going to go ahead and open up my solar panels. 23 seconds to the node. Can I make it? Whoops, wrong bay. Okay, 9 seconds. I'll just leave that panel sticking out through the hatch door rather. So I'm going to go ahead and fire up the main engine for this. I'm not going to thrust up all the way, and I'll use my RCS to fix whatever problem is left after that. Okay, 1 second. Okay, I got to 0.001. That's extraordinarily close. Do a little bit extra thrusting. Okay, that. So if you thrust and it starts to go up, then you need to thrust the other way. So RCS is definitely the easiest way to go here. Okay, well I can get it to 0.001. That's close enough. Go ahead and turn this retrograde. Now the next thing I want to do is I want to lower my orbit down to just skimming over the atmosphere. And this is looking like it's set up pretty well. So if I go over to my apoapsis here, the high point in my orbit, and over here I burn to lower my periapsis right down to 71 or so. And then when I orbit around here, the KSC should rotate right underneath it. And from here, when I do my deorbit burn, I will be lowering my periapsis and then, or apoapsis, and then deorbiting simultaneously. So I'm good with that. All right. Let's see. I'm going to turn off my RCS, and I'm going to warp around to my apoapsis thanks to Kerbal alarm clock. Okay, now I'm just going to watch my numbers here in MechJeb to see when my periapsis reaches 70 or 71. Okay, it's 72, that's close enough. Now we're going to go ahead and set up the deorbit burn. Now for this, I suggest you double click on the planet itself to center on that. Zoom all the way in. Now let's talk another key mod here, which is the trajectories mod. Stock KSP will not take atmosphere into account when your trajectory goes through the atmosphere. So if you start to go in, I'm sure you've seen this, your impact point on the planet moves around. It's almost impossible to use. With trajectories, I set KSC, and I tell it retro, and now I have this nice aiming point. This is from the waypoints mod, you can ignore that. But there's my aiming point there in green. And now what I'm going to do, I have 729 delta V left. I'm going to burn all but 50 of that. As long as you have more than 400 to burn, as long as your burn is more than 400, you'll be accurate. Any less than that, and the trajectories mod can't seem to get it right. Okay, that's 783. I need to not do so much. So I need 670 here. I'm watching the delta V required for this node down by the nav ball. Okay, there's my 670. And now I'm going to move the actual node around until my red X sits right next to the green one, like so. It's next to it so that I have room to deploy my parachutes. I want to pass just over the green part, the green cross, deploy my parachutes, and have room to deploy my parachutes. So what this is showing you here is that I'm going to do this burn here. Trajectories is showing me where I entered the atmosphere in the red line, and it's going to show me where on the planet I'm going to impact. So my path is going to be this, and the time it takes to fly that, this point here is going to move right over to here, and that's where I'm going to touch down. So now all I have to do is fly this node. Okay. I actually don't want to burn pretty much any more of my RCS. I want to keep this for landing. Okay, we come back into daylight. I'm going to go ahead and let my solar panels charge up those batteries. Okay, batteries are charged. I know I have more than enough juice to make it from here all the way down, so I'm going to go ahead and fold these up. Won't need the lights anymore. Okay, now I'm going to burn this node like I would burn any other node for accuracy. I see there that's a 10-second burn. If it doesn't say the time, just give yourself a tiny burst of thrust and it will then give you a time. Just a momentary burst. You don't really want to change anything, you just want to give it an idea of what your engine can do. So 10-second burn, that means I'm going to start the burn at 5 seconds to go before the node, and I'll finish it at 5 seconds after. Now as I get close to the end of the node, I'm probably going to switch to the map and just kind of visually watch that cross and see where it ends up. Here, I'll do this like this. The reason why I lowered my orbit, I don't think I mentioned this before, is just to decrease the amount of heating on this thing. I can't come in from higher. I've come in from 120 and I end up having to rotate it so that pieces of it don't burn up. Okay, 3 minutes to go. Okay, 5 seconds. Go. Okay, throttle down. I want to finish this accurately here. Stopping there. Now I'm going to delete the node, check out the map, see where I am. Okay, see, that looks like it's perfect. I didn't even need that extra 5 delta V. Okay. Now, all I need to do is hold this vehicle retrograde and just enjoy the ride. Now, you don't want to leave your RCS on here at this point because changing the weight of this is going to change how it decelerates in the atmosphere. So I've locked, I've turned my RCS off. I'm not going to use the engine again. Just going to cruise on down to the landing zone. And actually, I'm not even going to time warp high enough to get red there, where it's skipping frames. Now, another way you could do this without any kind of mods at all is you look at your surface speed. If you have that much delta V and you're right over the KSC and you burn all that to 0, you'll just drop straight out of the sky right onto the KSC. But that's a lot of delta V to hold in reserve. And I have some debris laying in this field right here, which means when I get close to it, I'm sure this thing's going to pause for like 5 seconds. Great. Probably right when I'm trying to deploy my chutes. Okay. Temperature's rising. Chute deployment unsafe. This is another thing I'm testing right now, is that will this decelerate enough just by the atmosphere alone that it goes subsonic and I can deploy my chutes. It is possible, and I have done it, to design a craft that is so kind of small and dense and heavy that it will penetrate all the way through the atmosphere and hit the ground at, Mach 2. And that doesn't work too well. Okay, my temperature is dropping. I think I maxed out around 860. Looking pretty good. The trajectories mod also gives me a little steering dot here. Shows me if I'm on my trajectory or not. Looking at the nav ball now. So now I'm just waiting for the atmosphere to slow me down enough to deploy the chutes. Honestly, I think I'm going a little bit long here. This might be kind of a close one. What I can do is I can actually steer a little more towards the ground. Yeah, the SAS just can't hold it. It's too stable. Yeah, I'll probably make it. Yeah. So now I can just deploy my chutes when I think I'm going to be closest to my center of my runway there. Or when I think I'm kind of running out of time. Of course, it takes time to slow this down with parachutes. This is looking pretty good. So that's the drogue chute from Real Chutes. This will slow me down to 80 meters per second, hopefully. And then it will detach, and I will press the spacebar again to deploy the main chutes. go. And those will slow me right down. So now I'm traveling at 5.6. I know that's within my parameters, my envelope. However, if I'm using mech jet, I'm going to switch this to up, and right before I hit, I'm going to turn on my RCS, which might help me slightly if it starts to tip over. The RCS will help thrust it upwards and keep it standing up long enough to recover. Right now, I'm only 580 meters from the center of the runway here. Not bad. I'm going to give a little bit of main engine thrust too, just to make sure it's a nice and soft landing. The trick is figuring out when I'm going to land, because these shadows aren't behaving. It's right at noon, it's hard to do. Okay, RCS on. A little bit of thrust. And there we go. Nice. 580 meters away from center of runway. Let's recover. So I recovered 98%, 49,895 from the parts. Not bad. So that is it. I can't think of anything more. If you think of questions, by all means, post in the comments. I would love to hear from you, and provide whatever tips I can. Thank you for watching. Have a great evening. Good night.